Here we have a video about just some basics of variation. We're going to start with direct and inverse variation. If I say y varies directly as x, y is directly proportional to x, y equals k times x, all of these three mean the exact same thing. So the key word there is direct. Directly, everything's going to change the same way. So if x goes up, y also has to go up. We can see that in this equation. The k is a constant, it's always going to be the same, but if x increases, the y also has to go up to keep things the same. If x goes down, y also has to go down. The inverse is just the opposite. If y varies inversely as x, or y is inversely proportional to x, y equals k divided by x. So in this case, we want the opposite relationship. So if x goes up, that makes this fraction bigger, okay, because the top stays the same, and then, smaller. X goes up, fraction gets smaller, then y also has to get smaller. If x gets bigger, this fraction gets smaller, y also has to get smaller. So to keep things the same, if this denominator gets bigger, x gets bigger, y gets smaller. That's the opposite relationship, and that's just named as an inverse variation or inverse proportion. This last one, y varies jointly as x and y. Really this is direct, the same thing, because directly would be a multiplication, k times x times z. If x goes up, again, y also has to go up. If z goes up, y has to go up. The only reason for the joint there is because there's two variables. So if both of these change in different ways, you're not sure what's going to happen to the y. So some of that's a little more ambiguous if you have more than one thing changing. We'll go and look at an example next. So if p varies directly as the square of x and inversely as y and the square root of z, what's going to happen with that equation? Alright, well first I look at what varies. So p varies, okay, so that tells me I'm going to have p equals, and then directly as square of x. So I should get some k times an x squared. Alright, so that first part, p varies directly as square of x, p is k times x squared. But it's also inversely as y and the square root of z, so I'm also going to get a division in this one. Alright, so here's the overall equation that comes out. P is k times x squared, we already found that. But then the inversely is y, so divided by y, and the square root of z, so divided by square root of z. Alright, so anything that I put in, I'm just looking for those keywords. Directly for multiplication, inversely for a division. If I finish off the problem, if p equals 10 when x is 2, y is 5, z is 4, find p when x is 3, y is 10, z is 9. The first thing I have to do is to solve for this k. So I'm going to use this first part where I'm given all the variables, values, to solve for the k. So I go in and plug in. P is 10, the x is 2, so we get 2 squared, y is 5, and the z is 4, so square root of 4 on the bottom. Go ahead and solve that out. Okay, so the square root of 4 is 2. That'll divide out with one of these 2's. So you just get 10 equals 2 times k divided by 5. And then at the end, k is 25. So multiply by 5, divide by 2. Once you got the k value, k is 25, now we can go ahead and use that in the second part. So the second part, find p when x is 3, y is 10, z is 9. So I have the x I can plug in, the y I can plug in, z I can plug in. Now I also have the k to plug in, and then to find a p. Alright, so we go in and plug all that stuff in. So they got the k 25, then 3 squared, y is 10, and the z 9, so square root of 9. Again, square root of 9 is 3. That will divide with one of these 3's, so I just get a 3 there. The 10 and 25, I can divide a 5 out of each of those. So I'm left with 5 on top, 2 on bottom. So 5 times 3 over 2, 15 over 2. So there's my final answer right there. P is 15 halves.